Good afternoon. This is Team Project Auxilium. This video describes the developing process of solar energy powered search and rescue glider. This video contains the selected component, CAD model, simulation, prototyping, and testing.
The renewable energy source our team chose was solar energy. Our design prototype will harness solar energy using a 10-watt solar panel and store it within a battery. This stored energy will be used to power a portable air compressor. As shown in this video clip, the solar panel is connected to the battery, which in turn is connected to the compressor. When we press the bottle, it shows that it is decompressed. Now setting the compressor to 5 psi for a demonstration, and the bottle can hardly be pressed into any longer. Our prototype will use compressed air stored within a similar bottle as a propulsion device. In order to launch the glider, it will be placed on a launch platform and will be launched along a guide rail, where the angle of the said guide rail can be adjusted depending on the situation. Once the glider is airborne, the payload mechanism will detach from the underside payload storage compartment of the glider. This detachment will be controlled by a timer and Arduino and will be actuated using a servo motor. The payload will have a parachute attached to it, and as the payload begins to fall from the glider, the parachute will open up due to the effects of air resistance.
In this section, I will be outlining the major parts and products that we have purchased, and I will be going through their uses and specs. Firstly, we have a portable air compressor. Portable air compressor requires an input voltage of 12 volts of direct current. Compressor can deliver an air supply up to 100 psi that will be used as the main source of energy. However, to power the portable air compressor, we needed to buy a solar panel that could output and run something that requires 12 volts. This solar panel is waterproof and can provide 12 volts, comes with alligator clips and a charge controller. We also bought foam boards which will be used for the wings and body of the aircraft, as it's a lightweight yet durable material. It is also easily cut and bent into the shapes that we need.
So this is the CAD model that we are basing the flying machine on. Because we were required to make the fuselage out of foam board, the shape of it needed to change into one that used straight edges. After calculations were done, a few dimensions were determined. Notable ones include the tip-to-tip wing length, the wingspan, the length of the nose cone and fuselage, and the dimensions of the rudder and elevators. As shown, the tip-to-tip wing length is 1.48 meters, and the wingspan is 0.665 meters. The length of the whole plane is 1.11 meters, and the nose cone is 40 centimeters long.
So we did some static simulations on SolidWorks using the following mechanical properties. These values are obtained from this site, as we weren't able to find mechanical properties for the exact kind of foam board we used. I took the values for the polystyrene foam density of 1 pound per cubic foot, although the polystyrene foam we got is no doubt more dense than that. For starters, I applied a 340 Newton load on the back end of the plane, as it is the expected thrust force applied by the Coke bottle on the back plate. We don't see much stress or strain applied generally on the fuselage, but there are some critical points of contact between the airfoil and the fuselage, and of course the possible shear stresses acting on the adhesives holding the plane together. For this reason, we'll probably be using some medium density fiberwood for structural reinforcements where possible. We also performed some drop tests from a 10 meter, 30 meter, and 50 meter height to test the structural integrity of the plane. And apart from the expected deformation, the plane did fairly well in terms of stress and strain, particularly in the 10 and 30 meter drops. But again, this doesn't account for the points of contact we talked about previously, and of course the strength of the adhesive used to hold everything together.
Let's go to building process of the prototype itself. The glider was entirely made from the foam board. The wings are made first using the 2 layers of foam board with a structural support inside the wings, and also for the profile of the wing. The flaps are drawn here but not cut into it, since we will be keeping them fixed for this project. The fuselage was made of entirely from single layer of foam board and bended into hexagonal. Rigid support throughout the structure was placed for rigidity and structure. The horizontal and vertical stabilizers were made using a single layer of foam board, and as you can see, the elevator and rudder is also drawn, but for this project we'll be keeping them fixed. For the cargo delivery and supplies, the underbelly will be utilized, and depending on the mission, a camera or sensor or the live turning supplies will be stored over here. The nose cone is also just attached using the friction, so it can be removed in case it is damaged during the testing. Thank you.